Hello everyone, this video is the third video of the module that we've been working on the electricity consumption data and pre-processing it. In the first video, we looked at some basic data cleaning pre-processing, and then the second video we looked at dealing with missing values. In this video, we're going to use visualizations to detect outliers and later on deal with them. So let's get to it. So as always, we import the required modules, and then also we read the data. These are the steps that we've already taken as far as cleaning the data, adding some columns, and also dealing with missing values. And now the data is at the state and there are no missing values. Now that we've taken care of the missing values, it's time to bring our focus towards outliers, see if there are outliers and how we are going to be dealing with them. So a good visual that can help us with the outliers, two good visuals. There are Histogram and Boxplot. So let's do a histogram first. As you remember, when we did a histogram, we noticed that there were some gap here that apparently there is only one or two or like in a very few number of data that are happening here, sort of like makes the histogram sort of like it has to push all the way here. So now that we sort of recognize this with our eyes, but we also want to sort of see these numbers, what they are. So the way to go about this is when you create your histogram, make it equal to outputs, because this plot not only does do the plot, but also it spit out an output that sort of all of the details about this visual is in that output. So I have this output here. Now I'm going to go ahead and print it and see different things about it. So when you print the output, this is the result of the print. When you print the output, you basically have two arrays. The first array is the frequency of what's on the visual. So here, this is 19, and then you have 92, and then you have 130, 234. So all of these frequencies that are shown in your visual are shown here. And if you look at towards the end, there are two ones that is pushing the visual to come over here. So those are two ones that we can't see, but they are there. And then the second array is really the let me select all of it first. So the second array is really all of these upper bounds. So the first one is it starts from 30,000 to 30,199, and then the second one is from 30,199 to 31,545. So these are the upper bounds of all of these numbers. So if I count the number of output 1, which is the frequencies, and output 2, they are 59 and 60. I mean, the number of upper bounds is one higher than the number of frequencies. So for us to have a better visual, like sort of like see what's happening here, I have created a data frame of saying counts all of the frequencies and then all of the upper bounds. And I'm inserting 0 in the beginning of it, so the number of the upper bounds of frequency will match. So there is like 60 and 60. So this is the result of it. So with this upper bound, we have 0. So you could think of it as actually 19. Maybe I should have done this. Maybe that's actually better. Let's run this. Yes, so with this upper bound, We want to change this to this. There we go. So with this upper bound, we have 19, and then 92 all the way, and 0 has been added in the end, which is 0 for the last upper bound. So anyway, now we have sort of an access to all of these upper bounds that we can look at and see where these missing values are, where these outliers are. So another thing we could be doing is to draw the box plot. And box plot is also another way to look at these outliers. And we can see there are a couple of flyers here, and there are two of these that are much even more like, sort of like more outliers than, these flyers. And if we draw these horizontally, we can see that what we were seeing in the histogram is conforming to what we are seeing in the box plot. So we can use the output of the histogram to sort of figure out, or like sort of filter out these two data and see what's going on with that. So we say if the consumption is greater than 96,201, 96,201, where is it coming from? It comes from here. So I know the numbers after this number are going to be isolating those two cases for me. That's where that number comes from. So if I say all of the data that their consumption is greater than this, and use that Boolean mask to create an outlier DF, then, so let's go ahead and actually do that first, and then say outlier DF. I will have a data frame with 2 rows, basically. So now that I know this is that data frame, now for each outlier, I want to do the same thing that I did for the missing values. I want to sort of see the points before and after it and see what's happening there. So once I run this, now I see the 20 points before the outlier and 20 points after the outlier. And I can see these numbers glaringly does not belong to that part of the data. A mistake could have happened, or other things could have happened that led to this glaring mistake. And you can think of this when such outliers happen, you can think of them as actually as missing values, because we know there is a mistake there and we don't have a data there. So that's the missing value. And the way we dealt with the missing value, we are going to deal with these two outliers. So, we get the previous 2 pairs next and 2 next, and we apply that formula that we came up with in the previous video, and sort of remedy the outliers. And once we do that, now we can see the outliers are much healthier. I mean, like these cases or the data around them are much healthier, because now we have used this formula that uses the 2 points, 4 points around that outlier to estimate it. So now that we took care of those outliers, let's do another box plot and histogram. See if still we have problems there. Now that we look at our histogram, it's much healthier. You can see that it's, starting at some point and, ending, and there are data all everywhere. So it's much healthier histogram. But for the outlier, we do have a bunch of flyers here. And it's prudent to investigate that before going to the next step, assuming that we don't have any outliers. So let's investigate that. And for us to be able to investigate them, we have to get access to them. And the way that we saw that all of the basic details of this histogram can be accessed through output of the function that creates this histogram, the same thing applies to boxplot. So now we are going to sort of dissect the boxplot and see what sort of information the boxplot is giving us. So this is the boxplot, and I'm getting the output from it. I'm calling it output, and I can see it has whiskers, it has caps. There's some data that's coming out. You have boxes, medians, flyers, and means. So the whiskers these are the whiskers. These lines are the whiskers. The caps, these are the caps, and the boxes, these are the boxes, and this is the median, and these are the flyers. So let's look at the whiskers. So I mean, one thing you want to pay attention to when you get to this level of getting the output from a function someone else has written, basically you have to figure out how they have given structure to the output of this visual. As you can see, the way it was done for histogram was completely different than it is the way it is done for boxplot. And of course, these visuals are also very different. But the point I'm trying to get across here is there's no standard way of expecting something out of these functions. Someone has written them, so you sort of have to figure out how they work. So if you say output whiskers, you will get access to whatever these values are. Whatever these values are. These are matplotlib line 2D. And these are sort of an object that matplotlib has. And if you, get what this is a collection. If you get the item and say get y data, it will basically tell you what is the y data. And these are the whiskers. So basically, the one whiskers start from 30,199 to 45,230, and the other one starts from 62,980 all the way to 89,484. So these are the whiskers. So you know where the whiskers are. And then also you can do the same with caps. And the caps are 30,199, the same thing as the whiskers. That's because that's they were the same thing here. And 89,484, and the same thing as this cap. So these are the caps. As this, the upper number for the whiskers here is the same as. But what we really want to look at are the flyers. So if we set the flyers and item get y data, now I have all the consumption value of all the flyers, and this is what actually I was looking for. I can also sort this. Now I can see start sort of from 89,000 all the way to 94,190. So now I have the Y's that sort of can be they're flyers, and these flyers could be an outliers. So now I have a way to access them because I have these numbers. So let's have a way to figure out if these flyers are outliers. There are two approaches here that I'm going to be using, and you can follow along. The first approach is sort of we do have this one box plot for all of the data, and we can see some of these are outliers, some of these are flyers. But let's say let's sort of separate the data into different hours and see if, based on different hours, are we going to have these flyers, and how are they going to look like based on different hours. So I am finding all the possible times, 0 to 23, and then for each of them I create a series and also create a Boolean mask and keep all of those data in this series. And now that I have this, I do a box plot, and I will have a box plot that for every hour, every possible hour, which is every 30 minutes. So this is 00, this is like, midnight, 30 minutes after midnight, 1 hour after midnight, all the way to 11:30 minutes. So now that I have this, I can look at these values and see that there are some of these that are very close. These are still there are flyers. There are a bunch of flyers out here, but these are so awfully close to their box plot. It could be that they are at their peak hours for a certain time. It looks like around 7 p.m., 9 p.m. So sometimes at their peak hours, they might be more. Some days that have actually been a real data that is just more than what normally happens in Belgium. But this one is way far from the cap of this box plot. So this could be an outlier. So we possibly could have one outlier. The second approach we can do is get this number from here and say I want to check every data that is sort of like greater than this number. And so actually this is a cap, I think. Let's see. Yes, this number. So everything that's above that cap, I want to see the 20 points before and the 20 points after that, and see if there are cases of outliers. So once I run this, actually I want to run this. Now I get a bunch of line plots that are going to show me the surrounding data of these flyers and see if these flyers are outliers or not. So this is the first one. As I investigate here, probably at some point that we pass, that threshold was 89,000, right? So it's like around 90,000. So like a bunch of these are after that line, right? But I can see that this is a part of this real data is happening here. And so it doesn't seem like an outlier. It is an outlier, but it's not an outlier in a sense that is not the correct data that I should be taking care of. It is a correct data, but it's just too different than the rest of the data. And I can see a bunch of these because you can see there are like, all of these points after. So that's why I have more than one of them. They are basically the same data. The same thing here. I don't have any concerns there. No concerns. And all of these seem to be okay data because, as you can see, they are part of the real data, like the data that's around them. And once you get to all of them, if there is no one that is concerned, that we can see that we do have an outlier here. So this one, you can actually see it's noticeably different than the points around them. So this is another example of the outlier that we were not able to see it just by using the histogram or the general box plot. So you had sort of like to dissect our box plot and do a little bit more investigation to figure this one out. So now we do the same thing basically. So I know this is this index. This is the index of the data. So I know that this is the row of the data that has this outlier. So I go ahead and address it the way I address all of the other data. Now this is, if you compare this with this, now you can see that this is like a healthier data, that you can see that that outlier has been taken care of. Now that I know that I don't have any other outliers, I can go ahead and take a look at my data. This is the data that I've been working on, and now the data is ready for the next step. So we have pre-processed this data as far as cleaning it, adding a few more useful columns, and also taking care of the missing values and the outliers. And now I can go ahead and save this data to a new CSV file and call it preprocess. You can use the df .toCSV, and it's going to save the file in the same folder as the Jupyter Notebook file.